Hello everyone, I'm Alessandra and welcome to a new episode of People Also Ask and We Answer, the interview series by Clearbox AI. In our latest episode, we talk about how companies can harness the power of AI, and we touched upon many points. For example, data management, organizational issues, and how to set the right expectation about AI, and also how to understand the results that come from it. Today, we're going to take a step forward and we're going to explore a theme about CI/CD. CI/CD means continuous integration, continuous delivery, and it's a concept that comes from the software engineering world, but it can also be applied to machine learning. So let's see how to do this with our guests, Luca Gilli, CTO and co-founder of Clearbox AI. Hi, Luca.
Hello.
How are you?
Hi, great.
And Gaspare Vitta, CI/CD engineering at Qarik. Hello, Gaspare.
Hi,
Thank you for
everyone.
joining us today.
Thank you for having me.
And Gaspare, maybe you would like to introduce yourself and tell us about your background.
I'm Gaspare. I'm from Italy. I work for Qarik as a CI/CD engineer. My main focus is around developer experience. So you can think of it like customer experience, user experience, things that you do for your external customers, like caring about your UX. The same you can do for your developers. So when you have a large organization, this is a huge problem. Maybe this is not top one priority for a startup, but as you grow, as your organization grow, you have more and more developers, you should start caring about that. So basically what I do is to improve the whole development workflow. I take care about toolings, all the automation, work with build systems, so also CI/CD, and then things like code quality pipelines and security pipelines. So basically my focus is to make sure that developers are happy and productive.
Okay, great. So this gives me a great opportunity to start this interview with you, asking the question that gives the title to this episode, which is, what is CI/CD? And can you give us some examples?
As you mentioned before, CI/CD is continuous integration and deployment, and is really a process that you embrace to deliver frequently your software. But actually not just software, but everything. It can be source code, it can be configurations, data, machine learning model, everything basically. It starts when when a developer pushes code from his laptop to the central repository. And when that happens, continuous integration system basically triggers a new instance of a pipeline. What you want to do in the first step is to make sure that that commit is good enough to be part of your code base. You want to do all the things like building the code, testing the code. You want to run also things like code quality checks, like make sure that that code is following all the linting standards that you have in your organization. At the same time, you may want to run some security checks. Let's say a developer is adding a new dependency, a new third-party dependency, and you want to scan that to make sure that it's following some standards that you have in your organization as well. The main goal of this stage is basically to give to developers a quick feedback. Since developers are basically waiting for the result of the CI, you want to tell them very quickly, this commit is good or this commit is not good, go there and fix it. And then once you pass that stage, you have other things like running more in-depth testing, like acceptance tests, for instance. You can have them automated and running. And then you reach a certain point when you have a good commit that you can call like a release candidate. And in many organizations, there is the need to run some sort of manual testing. So that is the stage where you do it. So you want to spend manual effort only on good commits. So things that have made through the whole pipeline till that point. And basically, you run the more tests, like you can do things like stress tests, capacity testing, or whatever other things are needed for your organization. And then you can promote it to production and basically release it to your users. I say there's a lot of things, there's a lot of steps. So my suggestion is do that one step at a time. Don't try to aim for the whole pipeline at first. It's not a one-day job. For many organizations, if you're maybe hosting your code on GitHub, just starting with GitHub Actions to build your code and run your unit test is already a huge improvement in productivity. At the same time, try to provide errors messages to your user in an actionable way. So don't say things like, hey, your unit test failed, but say, this unit test failed in this point, and this is the log message. So it's easier for developers to fix them.
Mm-hmm.
And at the same time, try to measure data of your pipelines. So how long it takes and how long each step takes. So it's easier to identify bottlenecks in the overall process.
One question that comes to my mind, because I'm not a technician and I'm having doubts about the use of the D of CI/CD, because I found that it can be delivery, development, deployment. What's the difference between these?
You can find also in literature the different meanings, but it means just give the software to your customers as soon as possible so they can validate it.
Okay,
it's just
thank
a process.
you.
Just don't go for naming, just a process.
Okay.
Try to do that as quick as possible and as reliable as possible.
Okay, thank you, Gaspare. So, like you were saying, CI/CD can be used also in machine learning besides other fields. And so, Luca, I wanted to ask you, how does the CI/CD work in machine learning?
Yeah. Thank you, Gaspar. It was very interesting, and as you said, machine learning is also can be seen as a software, because usually you have machine learning models which are implemented inside the tools, and you want to use these tools live, and you want to be able to constantly updating these tools, making sure that you don't break anything. So the same concepts for CI/CD apply to the machine learning. The only difference is that when you talk about machine learning, you have software, because you need software to write machine learning code, but you also have models and data. And models and data are two different entities that keep changing, because machine learning in production means that you are always exposed to new data, and you have to constantly improve your models. So you need to implement a lot of tests and version control to make sure that all these small changes don't break anything. And in case they break anything, you should be able to trace back to the last working version of a model. And in my point of view, like for example, I don't have a software engineering background, and I had to learn CI/CD, the most important concept of CI/CD, as many practitioners in the machine learning field, because my feeling is that a lot of data scientists are not software engineers. So there's a bit of a struggle in trying to understand what are the best practices and the best tools. And in my simplified view, usually I tell myself CI/CD for data scientists should be at least version control and test. So you should start by implementing these two concepts. And there are a lot of tools also to implement this concept for machine learning specifically. For example, version control for code you can do using Git, or Subversion using tools like GitHub. For data, now there are tools like data version control, which is basically Git for data, or for models, there's MLflow. And they're all very useful tools. The learning curve sometimes is slightly steep, because you need to learn how to use these tools, but they save you a lot of time on the long term, because there's this concept of technical depth. Like sometimes you like to make an easy choice. Oh, I'm working on a Jupyter notebook because life on a Jupyter notebook is so easy. But I'm sure most of 99% of data scientists have found themselves in a situation where they maybe wanted to go back to a different version of the model that they thought was working better. They couldn't do it because they didn't store it properly. And in my opinion, sometimes implementing this kind of practices is as simple as saying, as you would save a Word document every 5 minutes because you're afraid of losing progress on your Word document, I decided that I want to push my code to GitHub as a save button, or save my machine learning experiment with MLflow every time I stop working and do something else, because I know that it's a sort of checkpoint that I can always go back, and it's reproducible, because the objective is to make sure that if I go back after n hours, this model will behave the way it behaved last time.
Okay, thank you. So it's feasible even if you're not a software engineer to introduce.
Yeah, maybe you don't need to be, in my opinion, like a Git master to use Git. You can just do a commit, a push, and a pull. Some people are really experts of Git, but don't need to be a Git wizard to start implementing these first best practices. You can just use it as a save and load button.
So Gaspare, I will come back to you, because I recently read an article you wrote And one sentence in particular hit me, and it said, and I'm reading what you wrote. Releasing software shouldn't be an art, but a boring and monotonous engineering process. At first, it made me laugh, but I want to ask you, what does it mean? Can you explain to us?
If you're releasing your software in the right and healthy way, releasing it will be just as simple as hitting one button or executing one command. This is not the norm. There are a lot of anti-patterns that you can find. Like the most common is that software is deployed manually. So it's very easy to spot. You can just spot it from the documentation. Like there is a ton of documentation just for releasing the software. And that is a process that takes days, probably, for just one team of engineers. Also, when you release software in that way, you just do it once every, I don't know, every month, weeks. And that point, the delta of what you release, what is currently in production and what are you releasing, it's very big. And this means that there's a lot of room for errors in that delta. And if you find later on a bug or something, you will have to go and scan a lot of differences. Instead, if you release ideally at every commit that you do, difference will be so tiny that it's very easy to spot errors in that process. So this makes sure that the scripts that you're relying on are tested over and over, and then it will work reliably on the release day. And then another thing that is also painful for organization is that whenever you need to modify your production environment, you just do it manually. So then as well, you cannot roll back to a previous version, and that can be also dangerous. Ideally, everything should be checked in within the code. So your OS configuration, VM configuration, all the third-party dependency that you have, so that you are able to then recreate your environment in an automated way. They say that there are like two pillars that you should follow if you want to do CI/CD in the best way. The first one is the speed. You want to provide very quick feedback loops. So you want to release software as fast as possible. The second pillar is quality. You want to build your software with very high quality. So this means that all your testing suite and all that part should be automated. And you should move that as early as possible in your pipeline.
You were talking before about testing and version control. So I wanted to ask you, how do you test machine learning models according to the principles that Gaspare was explaining?
Yeah, it's a very complicated question because it's a very complex topic and it can be discussed at several levels. For example, most of machine learning models nowadays are written in Python. And one of the problems in Python, in my opinion, is the reproducibility. As Gaspare mentioned, these environments, a model that is trained and tested maybe locally at the developer's level should give exactly the same answers when it's in production. So you should make sure that when given this input, the output should always be that you verified while developing the model. That can be packaged as a test, for example, like you can set up a GitHub action saying, okay, try the model with this version of Python, with this other version of Python, with these requirements that you specified as dependencies, and make sure that the model is reproduced properly. And that's one technical aspect, in my opinion, very related to Python. The other aspect is that you should make sure that every single small change in the model should always either improve it or don't make it worse. So you can write tests also for that. And in my opinion, one very good strategy to write this kind of test is define a baseline. It can be like a very simple a dummy model, like a majority classified that makes the same decision of a model based on a very silly rule, and your model should always beat that kind of baseline. So that can be written as a test. If the accuracy or the precision for my new version of the model is worse, then reject this version of the model. That also helps defining if the metric I'm using for my model is good enough, because this kind of baseline can detect, for example, the fact that I'm using maybe accuracy for a very imbalanced problem, which is sometimes very common mistake in machine learning, because it gives you a false sense of security in terms of performance. Another aspect is when you have a macro idea that your model is doing okay, at least in terms of global metrics, it's really important to test it on some more local metrics. So to divide also data in segments to do a more in-depth analysis about the model behavior. And that requires a lot of hand tuning and definitions about what are the segments I want to analyze the model, because having two models that have a similar global accuracy doesn't tell you much. You need to understand also, for example, if you have a model that deals with personal data, if the model is working with a segment of people better or worse than before, it's important to detect also in terms of topics like bias and fairness. At Clearbox, we talk and think about the concept of synthetic data. So you can also think about using this kind of synthetic data as a testbed for models. It's a very new topic, and there's no framework yet for this kind of testing. But what we're trying to do also to understand whether this kind of synthetic data can be used to improve model testing. So by creating data in certain segments of population or point types can help understand better models during time and monitor them through testing.
Thank you, Luca. And I would like to close this interview by asking you to suggest some readings to do about this topic, because I would stay here for hours to talk with you too, but unfortunately we don't have enough time to cover all the topics about CI/CD. So maybe Gaspare, you would like to suggest some readings in particular? Maybe we can leave the links here somewhere for our audience.
Yeah, sure. So I will suggest two books about CI/CD. One is Continuous Delivery by Jess Humble and David Farley. It's like a classic in that space. And the other one is Accelerate, also by Jess Humble. And they will provide, let's say, the backbone and a lot of use cases about implementing CI/CD.
Yeah, I would like to suggest a paper called The Hidden Technical Depth of Machine Learning Systems, which is recognized as the paper that introduced the definition of MLOps. It's a very interesting read because it talks about going from DevOps to MLOps in machine learning. And a blog post actually from the blog of Martin Fowler about continuous delivery for machine learning, which is it's very interesting to understand what makes machine learning different from software in terms of testing and versioning.
Okay, thank you very much. So what we learned today with this interview is that CI/CD can help organization and people and tech people to make processes more efficient, both in terms of reliability and also in time spent on processes. So I think there also one value of this process is that teams can collaborate on finding the best fit for a process in their business. So it's very interesting, and I thank you very much for your precious point of views, and thank you, Gaspare, for being with us. It's much appreciated.
Thank you, guys.
Thank you, Gaspare.
Okay, so the interview unfortunately has come to an end, so I hope to see you soon to our next episode. Bye-bye.
Bye-bye.